Okay, system of equations is a set of two or more equations that contain two or more intersections. All right, solution to a set of equations. So what we're going to do is, so that's this first part. All right, and then a solution is basically the set of values that make all equations in the system true. For instance, down below we have a system. Notice we have two equations. That makes up a system. Remember, you use your slope. So the first one I used a slope of 2/3 and a y-intercept of 0, -4, and that's what I plotted right here. Then using 2, 3, up 2, right 3, up 2, right 3, I basically plotted my line. Then using the other information, that this one right here, I have a slope of -1/2 and a y-intercept of 0, 3. So I plotted 0, 3, and then I went down 1, right 2, down 1, right 2, down 1, right 2. Notice where they intersect is at this point right here. So at that point right there, at 6, 0, that's where they intersected. Now, one of the other things you have to do is check your answer. And how do you check your answer? Well, your x value is 6, your y value is 0, and you plug it into both equations. Notice I plugged in a 0 for y, and I plugged in a 6 for x. So that's going to be 0 equals 2/3 times 6. Well, what I ended up doing is this. The 3 goes into the 6 2 times. Then you multiply these two together. So 2 times 2 is 4. So you get 4 minus 4, which is 0. And you notice that this side is equal to this side. So that checks out. You do the same thing with the other equation. You plug in 6, 0. So 0 you plug in for your y. You plug in 6 for your x. So -1/2 times 6. So basically 2 goes in, or half of 6 is 3, so you have -1 times 6 is -3. And if you notice, if you have -3 plus 3, that adds to be 0. Therefore, 0 equals 0, and that checks out. We're going to do the same thing to the next one. On this particular point, you got to look at y equals 1/2 x minus 1. The y-intercept is 0, -1. That's this part right here. And then the slope is 1/2. So a rise of 1, a run of 2. Then, on the next equation, y equals x minus 3, your y-intercept is 0, -3. That's this part right here. And then your slope, now notice there's no number in front of x. That's an understood 1. So it's 1 over 1. Now, let's go ahead and go plot these. So at 0, -1, that's this right here, we're going to go up 1, right 2, up 1, right 2. Now, we could also go down 1, left 2, down 1, left 2. And notice it still creates the same line that we're looking for. Now, the one in blue, we're going to start at 0, -3. And again, it's a slope of 1 over 1. So we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, till they intersect. Now, if you notice, I can also go down 1, left 1. But if you notice, where they intersect is at that coordinate point right there, which is at 4, 1. Now, you've got to understand that you have to plug this solution into this equation and into this equation. All right, and that's what we're going to do next. Okay, so you're given the equation y equals 1/2 x minus 1. And you're given the equation y equals x minus 3. Well, according to what we've come out with right here, our solution is 4, 1. This is an x, this is a y, and we're going to plug those in. So for the y value, I'm going to plug in a 1. Bring down your 1/2. The x value, I'm going to plug in a 4. Now, half of 4, because it's 1/2 times 4, is actually 2. So you get 2, bring down your minus 1. And 2 minus 1 is 1. Now, those check out. Let's do the other side. again, I'm going to plug in 4, 1. So 1 is the y, 4 is the x. 4 minus 3 is 1, so you get 1 equals 1, and that also checks out. Therefore, 4, 1 is a solution. Okay, on this last one, what we're going to do is, again, you're going to take each equation. The one up here, this right here, the slope is negative 2. Okay, the slope is negative 2. That's negative 2 over 1. And the y-intercept, which is this, is 0, 5. So we're going to plot those points. Okay, so here we go. Here's 0, 5. And I have a slope of negative 2, 1. So down 2, right 1. Down 2, right 1. So I'm going to keep going. All right, so down 2, right 1. Now, I'm going to connect these. Now, it's going to be kind of difficult because I'm doing it freehand. So negative 2, 1. So notice I don't have a ruler. I don't have the ability to do a straight line here. The next one, all right, we're going to use this right here. Now, I want you to notice there is no y-intercept. It's an understood plus 0. So my slope in this case is 3 over 1. So 3 over 1, so that's my slope. My y-intercept is going to be 0, 0. So I'm going to plug in 0, 0. And 3 over 1, so 1, 2, 3, up 1. So right there. Well, you notice there's already an intersection. 1, 2, 3, and I can go down 3 and left 1. Well, I can go ahead and connect those. And this right here is my intersecting point. So that point right there would be 1, 3. Now, what you have to do with that is that you have to go back and double check your work. So we're going to take that solution of 1, 3, and we're going to plug it in. All right, so here we go, 1, 3. Let's plug it into both these equations. My y variable is 3. It's negative 2. Let me clean that up a little bit. It's equals, and it's negative 2. My x variable is 1, and then bring down plus 5. Same thing over here. My y value is 3. It's 3 times my x value of 1. Now, let's go ahead and clean this up. 3 equals, negative 2 times 1 is negative 2, plus 5. Negative 2 plus 5 is 3, so 3 equals 3, and it checks out. 3 times 1 is 3, so 3 equals 3, and it also checks out. Therefore, 1, 3 is a solution.